All right, inside this exercise, I'm going to show you how to find the scale factor, whether it be horizontal or vertical. Let me just read you the question in detail. Describe if the constant shows a horizontal or vertical dilation and state the scale factor. So what we got here is a parent function of y equals x to the power of 4, and the transformed function is y equals x to the power of 4 divided by 6. So we need to determine, is it vertical, is it horizontal? Well, we got horizontal here, we got vertical here. Which one is it? Well, if I write this out in the proper form, this is in the form of y equals kx to the power of 4, which equals 1/6 x to the power of 4. As you can see, the scale factor is out the front. It's not in the function. It's not in the function. It's actually like this. So it's a what? It's a vertical scale factor. So we got the k out the front like that. It's in that form. And that k, that constant, the vertical scale factor, happens to be 1/6. So let me just write that out. K equals 1/6. What does that tell us when we have a k of 1/6? Well, we know that if we have a k, 0 less than k less than 1, a k that's in there like a fraction, 1/6, then it means that the function is going to be vertically compressed, meaning it's not going to grow taller and closer to the y-axis, but in fact it's going to go away from the y-axis, actually kind of closer to the x-axis, so it's going to be compressed. So if you can imagine this function here, which is the parent function y equals x to the 4, let me just write it in. This is y equals x to the power of 4. Then if you can imagine that being squashed down, compressed, it's going to come more out. So if I was to draw y equals x to the power of 4 with the 1/6 applied to it, 1/6 x to the 4, it's going to look something like this. It's going to come out wider. It's going to approximately something like this. So that's y, let me write it here, y equals 1/6 x to the power of 4. So can you see how it's wider and further away from the y-axis? Even though it is a vertical dilation, it's a vertical compression specifically, not a vertical stretch. If it was a stretch, it'd be going closer to the y-axis, but it's not. It's actually a compression. So again, it is compressed. The constant is a vertical scale factor, and the vertical scale factor k equals 1/6.